the problem that we have, and we did previously, gave us an answer. $35 times 35. 1,225 choices. But now I'm going to change the problem a bit. I'm going to add the case where you don't pick the same item twice on a weekend. So if I picked, say, a fried fish burrito or taco the first or on Saturday, I'm not going to pick a fried fish taco on Sunday, because I have satisfied my craving on Saturday. I'm going for something entirely different on Sunday. One has to stop, think, and ask, well, is it going to decrease the number of options compared to what I had previously, which is 1225? It will decrease because I'm limiting myself, limiting the number of options for the second day. So if I start with 35, the next day, I don't have 35, I only have 34. So Saturday, Sunday, 35 options for Saturday, 34 options for Sunday. So we are pretty much losing 35 choices. If we multiply, I believe, get 1,190. The main reason that we look at the fundamental rule of counting and these specific cases within the fundamental rule, because when we find probabilities, we are not interested in writing out all the possible combinations explicitly. What do I mean by that? Even though I know there are 35 varieties of food items, food options at the Mexican restaurant that we're talking about, I don't want to sit and write burrito, taco, fish burrito, beef burrito, veggie taco. So I don't have to write every menu item combination for each weekend. Now that will take forever. But all I need is the number of possible items, which is why we are doing the counts. When we get to probability, you will see exactly as to what I mean. It will boil down or come down to looking at the cardinality for the set of outcomes. So this is fine. I have 35 times 34. I can write this easily, not a big deal. But what if I changed the above case without replacement, and instead of a weekend, just do an entire week. Now, we don't know if it's going to happen every week of the year, but I'm just saying an entire week. Well, how do we go about doing this? Entire week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. The previous case is where I start with 35 and I don't go for the same menu item twice. I start with 35 ways, 35 becomes 34, then 33, 32, 31, 30, 29. Well, that is all nice and great that I'm able to write this out numerically and come up with this number. But do we really have to do all this work? Imagine if I just extended this to an entire month, month of July, for instance. Do I really want to sit and write this all out, even as numbers? First, I'll say I don't want to explicitly write the combinations. All I need is the counts. But even to write the counts when the number of days increase from 2 days to an entire week to, say, a fortnight to a month, things get complicated. There has to be an easier way. This process of selecting this specific case is what we call the N permutation or case. Sure, the previous one that we did is also a permutation, but we don't write it the way we do with this formula. So this is just N P R. So we have N distinct items in total. We are picking R items, and the order matters, and you're doing it without replacement. So in my restaurant example, I have 35 possible menu items to begin with, going for 7 days. So R is 7, because I need to make 7 choices. And we know how to get that answer. It's right here. But is there a better way? There is. But in order to use the formula, we need to know a few things full of excitement, as you will see. Full of excitement. So NPR stands for n permutation r, which is n factorial divided by n minus r factorial. So what is a factorial? When we write 5 factorial, it simply means 5 times 4 times 3 times 2 times 1. Instead of writing that elaborate expression, we simply call it 5 factorial. We've got to be careful. 0 factorial is not 0, it's 1. And 1 factorial is 1. So, our example, we have 35, permute 7, n is 35, r is 7, 35 factorial divided by 35 minus 7 factorial, which would be 35 factorial divided by 28 factorial. Now, we can use our calculator, 35, to get the factorial, press Mart over to PRB, option 4, brings up the exclamation, excitement. The next time you need some excitement, you can just, go to this option, turn on the calculator and keep pressing Mart. Divided by 28 Mart over to PRB, option 4, factorial, enter. That's what I get. And don't forget, at the very end of the screen, right inside, there is E10, which is scientific notation for 10 raised 10. That will tell you the number of decimal places that you've got to move. So we have 3.389158808. Okay. Multiplied by 10 raised 10. That is the E raised 10 part. So if you move the decimal, you have 3.389158808. Those are the total number of ways or options you have for an entire week. Assuming that automatics, eating a chicken taco of a particular variety of chicken taco on Friday is not the same if you switch it to another day. I feel like even this calculation is a bit too much. So there is actually an easier way. In your calculator, you press the number, total number of options that you have, which is 35. Math. over to PRB. Option number 2 is NPR. So select 2, followed by R. R in this case is 7. Enter. I get the same answer. So consider this case. You entered a speed dating event and you are seated at a table and you're only going to meet with one person. That person is going to come from the remaining attendees. So once you talk with a person, you don't need to speak with the same person again. You've got to look at the other people, plenty of fish in the sea. So, or at the event. So the maximum you can meet though, that particular night is 12. So the same person is not going to come back to your table, and the maximum would be 12. And if someone, or even you, person who attended the event, starts to wonder, well, in what order did I encounter these wonderful speed dates tonight? How many possible ways are there? How many possible orderings are there? So the ordering matters to us because I'm reflecting on what order they arrived. And obviously it is without replacement because the same person is not going to come back to your table more than once. So in our case, we have 72 attendees, not including yourself, because, you can't be speed dating with yourself, and what's the point of attending the event? So there are 72 other people, and 12 come to your table, and the same person is not going to come to your table more than once, so it is without replacement. Since the order matters to me when I'm reflecting, thinking back as to in what order these people came to your table, I'm looking for the number of permutations, which is N, P, R, 72, P, 12. In the calculator, I'm pressing 72 first. Math over to PRB. Select number 2, which will bring you NPR, followed by 12. The 12 people who are going to come around or who came to your table. Those are the number of possible orderings that are possible, or excuse me, that's redundant. Those are the total number of possible orderings if you looked at, or if you start thinking about the people in order. Now, it is certainly a huge number. And imagine you start wondering, well, oh, hey, you went to this speed dating thing, you encountered 12 people, there were 72 people. Well, what are the chances that you really liked the person who was the 4th person you met? out of all these possible permutations you have, you want to know, well, what are the chances? What is the probability that you like the fourth person who showed up at the table? In order to figure that out, there's more to it, but you don't have to explicitly write their names down, find every possible combination. All you have to do is come up with the count, and that would help us find the probability, which is the entire purpose of permutation, the fundamental rule of counting, etc. Okay, so that is permutation. If you recall, so we looked at R distinct items from N distinct items. That's perfectly fine. But sometimes there is another type of repetition, but it has nothing to do with, how to put it, going back to the same menu item or the same person coming back to your table at that speed dating, and that speed dating example. Rather, consider a case with some similar items. What do I mean by that? We typically use a simple example, such as this one. Let's see, I am, so how many orderings of letters can you form using the word Collier? Problem here is, in our permutation example, one of the conditions was that there shouldn't be replacement. In addition, we wanted the N items to be distinct. So here I have COLLIER for 7 items, but not distinct. So I want to know the number of orderings that I can form using those 7 items, all 7 of them. The formula is a bit simple. There is a rationale behind it, but it's beyond the scope of this class, and I don't want to confuse you. So we'll just go with the formula. First, you look at the number of C's, the number of O's, the number of L's, the number of I's, the number of E's and the number of R's. 1C, 1O, 2 L's, 1 I, 1 E, 1 R. In total, I have 7 items. So the number of orderings in this case is simply n factorial divided by the factorial of each case. So total n factorial divided by nc factorial, no, nl, ni, ne, nr factorials of each. So 7 factorial divided by 1 factorial times 1 factorial. Mind you that there are 2 L's, 2 factorial, 1 factorial, 1 factorial, 1 factorial. So we know 1 factorial is just 1. The denominator would simply reduce to 7 factorial over 2 factorial. Seven math over to PRB, number 4, divided by 2 math over to PRB, number 4. I get 7 factorial over 2 factorial, which is 2,520 ways.